So we have a higher order derivative question with an expression that involves ln of x. So let's start by doing derivative maybe about 3 times, okay, 4 times, and we have to try to see if there's a pattern. Okay, so we have y is equal to x to the power of 8 ln of x. So let's do that once. Y prime, you get 8x to the power of 7 ln of x, plus you get x to the power of 8 times by 1 over x. So that's going to give you x to the power of 7. Okay, so let's do that again. The second derivative is 8 times 7 times x to the power of 6 ln of x plus 8x to the power of 7 times by 1 over x. So you get x to the power of 6 here, and this also becomes 7x to the power of 6. Now note that we actually need to differentiate this. We just did it twice, so 7 more times. So note that this term here is just going to disappear if you do with this particular term derivative 7 more times. This is also going to reduce to x to the power of 6. So that's also going to disappear if you were to differentiate 7 more times. So the only thing that actually matters is this part. Okay, so let's just do that one more time, ignoring these two because I know they're going to go away. So you get 8 times 7 times 6x to the power of 6 if you differentiate that by product rule, 5 ln of x, and we have 8 times 7 times x to the power of 6 times by 1 over x, so we get x to the power of 5. Again, this is insignificant because by the time we get to the 9th derivative, it's going to disappear. The pattern for this is pretty obvious, right? So when you do 3 derivative, the third derivative, you get 8 times 7 times 6. There's 3 numbers here. So this is a factorial pattern. So this is in fact 8 permute 3. Okay, so 8 permute 3 is written this way. 8 factorial divided by 8 minus 3, 6 factorial. Okay, the other pattern is the power here. So when it's 3 here, it's 5. Okay, so we started with the 8th power, and when we got to the 3rd power, right, we got up to 5. So the 8 essentially trades its power with the derivative, right? So 3 and 5 adds up to 8. So let's first figure out the 8th derivative. The 8th derivative then will be 8 times, so 8 permute 8, which is going to be just 8 factorial. So we're going to x to the power of 0 here, and attach with a ln of x. So this is the 8th derivative. Okay, this simplifies 8 factorial. X to the power of 0 is 1, so we have ln of x. So the 9th derivative, the only function that's left over is this ln of x. We're going to have 8 factorial over x. Okay, that's the 9th derivative.